Okay, the reciprocal equation. The parent function for the reciprocal is y equal to 1 over x. Remember that one? Kind of funky. It's kind of weird looking. But it is so much fun. And how do you graph this one? Well, you pick some nice numbers and you got to figure it, just got to think about the rest of them. So, as I've been doing these, I've been showing you like doing a little XY table if you get stuck and you don't know what it looks like, you don't remember what it looks like. Do you need to know what it looks like? Because guess what we're starting tomorrow? We're going to take every single one of these and we are going to shift it, because shift is going to happen a lot. We are going to stretch them. We are going to flip them. Right? We're going to rotate them. So, I need y'all to be able to do this. So we're going to make a little XY table to get a feel for what this graph looks like. So, obviously, what happens when you put in 0? When you put in 0, what happens? What is 1 divided by 0? What is anything divided by 0? Can you divide by 0? No, not till you get to calculus. You are not qualified to divide by 0 till you get to calculus. For us right now, it's undefined. Undefined. If it's undefined, what is there? What kind of asymptote? A vertical asymptote. That is exactly correct. There is a vertical asymptote here. So this thing right here is a vertical asymptote. There's going to be another asymptote. We're going to find it in a minute. There's actually a horizontal asymptote too. But we'll get that when we get to the end behavior. Okay? All right. We have a vertical asymptote. We will not be crossing it at all. You can cross horizontal ones sometimes for some functions. This one you can't. You can't cross its horizontal, you can't cross its vertical, and later this week I will wear a special t-shirt just for y'all because of this. Yeah, calculus saw it earlier in the year. All right, so here we go. So I'm going to pick a nice number like 1. What's 1 over 1? 1. Okay, so I know that is a point. It's a real thing. Okay, what happens, because we're going to need to, we kind of get a feel for this. I need to know what's going on to the left of it. So what I should have done is started with a half, because 1 is just not enough. Look how close that is. We got to figure out what's going on at this asymptote. So let's put in a half. Okay, that's dividing by a fraction. When we divide by a fraction, what do we do in order to multiply by it? We flip the fraction, right? So it's 2. OMG, it's 2. Because think about it. Just think about it a minute. If it's reciprocal, does that mean that that's how many pieces I'm dividing something into? So if I'm dividing it into 10 pieces, they're pretty small, right? But if I'm dividing it into halves, that's twice as many, right? So as you divide by a smaller and smaller number, does it get larger and larger? Yeah. Larger and larger. So does that mean this is going up forever and ever and getting closer and closer but never reaching 0? Now what happens if I put in 2 down here? What's 1 over 2? 1/2. Do you see the trend now? It's a half right here. Do we need to do any more points? No, because you can't see them anyway. What is it doing? What's it approaching but never reaching?
0.
It's approaching 0 but never reaching. Now think about it. If I take a half step as I'm going to the door, I'm going to go half the distance, and then I'm going to go half that distance, and then I'm going to go half that distance. Am I ever going to get there? No. I can divide by a smaller and smaller fraction. I never get to 0, but I approach it. I get infinitely close, but I never get there. That means it goes like this. And hence, we have a horizontal asymptote at x equals 0, and we have a horizontal, no, I said that wrong, that's a vertical asymptote. Psst, that was silly. Okay, vertical asymptote at x equals 0, we have a horizontal asymptote at y equals 0, and guess what? We have another side of this. Can we plug in the negative numbers now? What we're going to do is, we have x, we have y, we're plugging in, we know 0 is still 0. We're going to plug in a negative 1/2 and a negative 2. What's negative 1 divided by a half? How many halves are in 1 cup of flour? 2, right? So is this negative 2? What's 1 divided by negative 2? Negative 1/2. So we're going to come over here, negative 1, and then it's, oh, I guess I should have put the 1. I should put 1. Yeah, hang on. We got to put our 1 in here. I got rid of it. I shouldn't have. So we have a 1 and a 1, and then we have 2 is a half. Over here, what I should have done negative 1, negative 1, negative 2, negative 1/2. So we're graphing that. So we got negative a half is negative 2, and we have negative 1 is negative 1, and we have negative 2 is a half. Is this going to do the mirror image? And what does my graph look like? It looks like that. You need to know the general shape. Are those the only 3 points I need to see on each side? This is one of the cases where 6 points helps. The minimum is to draw 5, but there are some graphs, and I'll tell you which ones, that you don't need. Like for the base ones, for the exponential function, you only need 1 point. For a base 2, you can do me 3 points or 4 points. For this one, 6 points really helps. For a polynomial or the algebraic ones, I want 5 points. Okay, looking at that, can we talk about this thing now? All right, so now we're going to talk about it. So looking at my graph, what's the domain? Can I have any x this way and any x that way? What's the only x I can't have? 0. So normally you would say all real numbers, but x not equal to 0. We can't do that. All right, you can do that, but I'm not going to give you credit for that. I need you to think in terms of interval notation. So now what we're going to do is, are we going to go from negative infinity to 0, open parentheses, and then 0 to infinity, open parentheses? It doesn't ever reach 0. Goes right up to it. Is that how we show it? You were showing that 0 is not included. Domain, we got. What about range? Same thing. Negative infinity to 0, not included. 0 to infinity. I wish I could write. I remembered some tricks this weekend on how to use my pen. I haven't used it in too long. Okay, x-intercept. Does it ever cross the x-axis? None. There are none because it's an asymptote. Oh, I can't spell either. What about y-intercepts? None. Why? Asymptote. I just cannot seem to do that today. Okay, we got asymptotes going on. No, there is only one S. I can spell. All right. In behavior, as my x goes to infinity, what is my y going to go to? 0. As my x goes to negative infinity, what's my y go to? 0. Okay, now this gets to be fun. We actually have an increasing and decreasing intervals, maybe. Or it's a little different, it's not what you're used to. Look at increasing. Is it ever increasing? Moving from left to right, what does it do? It goes down here. What about over here? It goes down. Weird, huh? There are no increasing intervals. There's none. But what about decreasing? Yeah, but what does it match? It matches the domain, right? Can it be 0? It decreases from negative infinity up to 0, but not including 0. It decreases from 0 to infinity, but it doesn't include 0. So is it just like the domain? So it's negative infinity to, oops, that's a bad comma. comma 0, and then 0, comma infinity. 0 is not included. Once you've said that that's not in the domain and range, should you put 0 as an answer for anything unless it's an asymptote? No. Continuity, is it continuous? No. Does it have a removable discontinuity? Can you remove an asymptote? No. What does that leave? It's a non-removable discontinuity at what? At x equal to 0 specifically. Okay? So it is continuous, and it's the same domain. Is it continuous as long as I'm between negative infinity and 0? Yes. And as long as I'm between 0 and infinity. Those pieces, it's continuous. It's not continuous over the whole thing. We have a non-removable discontinuity at x equal to 0.
What's this continuity?
A non-removable. Removable means that you can factor out. You can't factor out this. All right, and the additional information is asymptotes. We already put it down, but we're going to summarize it. Asymptotes at x equal to 0 and y equal to 0. Am I making a big deal of that? I am. Because if you can find your asymptotes, you're in great shape. The problem is y'all can't ever find your asymptotes.
What is this graph used for in the world?
Can I get back to you on that? We need to finish this, okay? We'll discuss it later, but that's an important function. It really is. It is used in things, calculus specifically. All right, moving right along. We got our favorite absolute value. Is that what y'all started when y'all were Algebra 2? Did y'all move this thing all over the place? All over the place. Y'all did. This was like the favorite function. Okay, absolute value, the parent function is y equal to absolute value of x. What does that mean?
It can't be negative.
It can't be negative. So what it does, it takes everything that's negative and makes it positive. What does that look like when you have a graph? Everything below the x-axis gets what? Flipped up. It's that simple. Everything below the x-axis gets flipped up, so the graph's always just like it bounced off. It's like a mirror. It bounced off the x-axis and came back up again. Every single time. So if you can graph the positive parts for the negative parts, just reflect them up. So if you have to, do a little light sketch of the whole thing and then flip up the negative parts. It's the best way to graph this. This one is easy, but can I do absolute value of anything? I can do it of anything. Anything that goes negative, I can do it of everything positive too, but it's meaningless for that. Okay, we're going to do this one. So if you had the equation y equal to x, would it be that line that goes on a 45-degree angle here? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Are those all good? So we could go ahead and graph those. We can go 0, 0, 1, 1, 2, 2, 3, 3. These are all good, right? So you can draw that in. No problem. That part's okay. What about negative 1, negative 1? You would be going down, but that I can't do that. I can't do that with an absolute value. What do? I go up. And at negative 2, I go to positive 2. And at negative 3, I go to positive 3. Do you see the trend now? All I do is go like, oh, I'm just going to go up. Because the part of the line that was down here, it got flipped up, right? Does everybody see that? And that's the absolute value of x. Is it easy to draw me 5 points? 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Just draw me a few to get it straight, right? So you don't mess it up. Okay. Oh, let's make this a little smaller so you can see it. What's the domain? So, Mo, it's negative infinity to what? Does it go on forever and ever? Infinity. What about the range? There's where it's a problem. Whoa, what is it? Yes, and is 0 included? Did I put a dot there? Yeah, so 0's included, and I go to infinity. I have no negative numbers. 0 is okay, but no negative numbers. None. Nada. Do I have an x and y intercept? 0, 0 for both of them, right? 0, 0, 0, 0. Go back to this. Okay, in behavior, as x approaches infinity, what does y approach? What? As x approaches infinity, what does y do? Oh my God. I'll repeat. As x goes to infinity, what does y do? Thank you. Infinity.
Beyond.
And beyond, yes. As x goes to negative infinity, what does y go to? No. Oh Lord.
Infinity.
This is x going to infinity. What's the y doing?
It's going to
Infinity and beyond. Look at the graph. Y'all are random number generators still.
But is infinity a number?
No, but it is a concept. Just accept it and move on. Still. Increasing. Uh-oh. Now we got both kinds. As I go on my left-hand side of the graph, as I go from left to right, what's happening? Is it going up or down? Is this my decreasing interval?
Yeah.
What about on the other side?
Increasing.
Ah, so we have both now. So the increasing interval is from 0 on. It at 0, do you see it's both?
Yeah.
So you can't, zero's not included. It's not increasing or decreasing because that's where it changes. At the place where it changes, we don't include that point. So on the increasing intervals, and by the way, I'm telling you that for future reference. If you ever take calculus, in calculus it's a big deal. Here it's not so much. I'm going to 0, but I'm not including 0. So for increasing, it's from 0 to infinity. For decreasing, it's from negative infinity to 0, not including 0. All right, is it continuous? To draw that, did you have to pick up your pencil? Are there any removable or non-removable discontinuities? Any holes? Any asymptotes? No, so it's continuous over what? What to what? Negative infinity to infinity. Say it negative infinity first, but you're right. So it is continuous from negative infinity to infinity and beyond. I'm going to rewrite that so it's a little neater. Okay, additional information. This is important. I need y'all to, this is what I taught my Algebra 2 kids to help them with this. You kind of touched on piecewise, but this can be written as a piecewise. Can be defined as piecewise. That means I can write this as f of x is equal to, put the little bracket, there are two parts. It is equal to x for x greater than or equal to 0. Is that drawing this part right here? We're drawing this part right here. When I draw that part right there, I am drawing x. When I am drawing the other part, I'm writing as negative x. And that's for x less than 0. That means this part. This part, that's y equal to negative x. This part is equal to y equal to x. Do you see how it's two pieces put together? When you get to calculus, if you remember this, it helps you on so many things that we do in calculus if you understand piecewise functions, which we are going to do. Can I take those two pieces and put them together? Is that the same thing as an absolute value? It helps us with other future concepts. All right, we have now finished all the notes, so you can now do all of the graphs, except y'all forgot how to do things. So we're going to talk about one graph. Let me pull up that worksheet. Let me see if I can find that worksheet, if I've already got it on here. I do. go to your actual assignment. Go all the way down to, I thought there was one y'all couldn't do. Oh, here it is right here, actually. All right, looking at this function right here. The y, yeah, number 9. Not number 8, number 9. Number 9. We have y squared equals 2x. Uh-oh. Okay, no. When you square root it, are you going to lose information? Unless you remember plus or minus. Is there an easier way to do this? This is a sideways parabola. What we're going to do is we're going to solve for x. We're going to divide by 2. We're not solving for y for this one. We'll do that in a minute, but I want to show you the easy way to do that before you solve for y. If we divide by 2, we get x is equal to y squared over 2. Does that look like a parabola, right? That has remember when we do transformations there's an a, and it's a half. Does that mean that it's been flattened out? It's going up half as fast, right? Does that make sense? If that was y equal to x squared over 2, you would say that that's the parent function x squared that has been transformed by being compressed by a half. But what if we turn it sideways? Is that sideways? Right? It's a sideways parabola. So we're going to do the same thing we would do. The parent function for a sideways parabola is x equal to y squared. And that starts at 0, and it goes sideways 1, 1, and then 2 is 4, like this. That's a sideways parabola, right? That's x equal y squared. We need the same thing, only we need it to go up half as fast. So this is x equal to y squared, but we want half that. So that means 1 is going to, instead of being 1, it's a half. It's going to go half the distance. Instead of going to 4, it's going to go to 2. Right? And instead of 9, so at 3, instead of going to 9, it's going to go to 4.5. So is it just a fatter parabola? And the easy way to do this, so I'm going to erase that blue. I'm going to erase that out of your way. That's the parent function. We're going to get rid of it. Is that what it looks like now? And how did I get those points? Let's go get the points. So we got x and we got y, but instead of choosing x, are we going to choose y? At y equals 0, what is x? Put a 0 on there, it's 0, right? If y is 1, what's x? 1/2. If y is 2, x is 2. If y is 3, x is 4.5. Do you see how to choose them? And then, what about if I do the negative? So then the other thing is the negative. So I'm going to go, I'll do it over here, x and y. If I choose a negative 1, it's negative 1/2. No, it's not. It's 1/2 because it's just going to square it. I'm a goofball. 1/2. And negative 2 is 2. And negative 3 is 4.5. Is that how I got those points? So I'm going to graph it because I didn't graph it very pretty. I'm going to graph it again. Is that okay? So let's start over. If we're starting from scratch, pick your y's, now graph your points. So I know it's, make it nice and big so I can actually see what I'm doing. It's at 0, 0. And then at 1 for the y, it's a half for the x. For negative 1, it's a half. For 2, it's 2. For negative 2, it's 2. For 3, it's 4.5. For negative 3, it's 4.5. I could keep going because for 4, it would be 16 normally. Half of 16 is 8. I can actually graph that point. I can keep going because I have room. Is that a prettier parabola? But it's a sideways parabola. I think that's easier to do. Do you think it's easier to do than roots? Because your other choices do a square root. That's a pain in the butt, my opinion, personal opinion. This is so much easier. Because otherwise you have to do plus or minus the square root. Do y'all want to see that? Okay, your other choice on this is instead of doing this, your other choice is to do, all right, so I had y squared equals 2x. I would divide by 2 and I get, no, actually just take the square root. So we're going to take the square root of both sides. So that means y is equal to the square root of 2x. That means I've taken the parent function of square root of x, but what have I left off? Hang on, I left something off. It's plus or minus the square root of 2x, right? Because if it's negative and you square it, it's positive. So does that mean that I have one part like this and one part like that, and I'm putting it together? You understand what I'm saying? No? Is this why this is a pain in the butt to me explain? Is the other so much easier? Do you see why I did it first? Because this just hurts y'all's head. Why would I do it that way? Because what it is I got to do this piece first, and then I got to do the bottom piece. And why would I do it that way? Because y'all's head hurts just looking at it, doesn't it? Is this so much easier if you'll do it my way? There is a reason I teach it that way. It is so much easier. So y'all need to try it, okay? Your mission now is to graph all those. Why are you graphing all those? Because it's getting back, y'all need to get those skills back. Y'all are rusty, if you ever had them. And we are about to do transformations without, this is all without a calculator. All of it, you are capable. Have y'all all gone and got your four-function calculator? Go to the dollar store, go get one. Go to Target, go to Walmart. I don't really care where you go. Go to the drugstore.
Oh, we supposed to buy one?
Uh-huh.
I already have one. I just didn't.
Yeah, just have one. You just need a four-function? Just show it to me and I'll approve it. Okay, we are done with